Greetings. Today we're going to talk about solving exponential equations and logarithmic equations. If we have two bases that are the same, that are raised to different powers, we can assume that those powers are equivalent to each other. And that's going to be an important property that we're going to use in order to solve exponential and logarithmic equations. So our first equation is 2 to the power of 3x minus 7 is equal to 32. So we're going to start by showing how to algebraically solve this. Well, notice that our bases are not the same, but I do know that 32 is the same as 2 to the 5th power. So now that my bases are the same, I can set my exponents equivalent to each other, giving me 3x minus 7 is 5. Now I can simplify by adding 7 to both sides, giving me 3x is equal to 12. Divide by 3, so x is equal to 4. We want to check our work to make sure that we algebraically simplified appropriately. So wherever I see x, I'm going to insert 4. 2 to the power of 3 times 4 minus 7. That gives me 2 to the power of 5 when I simplify my exponent. So it is a true solution. We also could solve this graphically. By finding the point of intersection. So using Desmos, I would set y equals 2 to the power of 3x minus 7, and on a second line I would set y equals 32. And I would see at the point x equals 4 is when these 2 points would come together. So that would be their point of intersection. A property of logarithmic equality. As long as m and n are greater than 0, as well as our base, and our base is not equal to 1, if we have the same log base a of m equal to log base a of n, we can say that the of portions are equal to each other. So on the example 2, I have solve 3 to the power of x equals 20. Well, I noticed that their bases are not the same, and I cannot rewrite 20 using a base of 3 to some power, so I can't use our base exponent property above. But I do know that if I multiply the left side by something and the right side by the same something, we do know it keeps its equivalence. So what I'm going to do is multiply each side by the logarithm. Now we can apply our rules of logarithms, because I can take my x value using my power rule and bring it out front. Now I can divide each side by log base 3. Gives me log base 10 of 3. So when I do that, I have my x value by itself and 2 logarithms which I can divide since they're just numbers, giving me x is approximately 2.7268. Oops, I'm sorry. We're checking our work. If we're going to plug in x to our exponent, we get about 20, which matches up here. So the solution is about 2.7268. This portion here that we found, we would call this the exact answer, since it's not simplified by rounding our decimals. We could also check this by working it graphically, so you can also check your work using Desmos, where I would set y equals to 3 to the power of x on one line And on another line, I would set y is equal to 20 and find their point of intersection. Solve 100 e to the power of 0.08 t is equal to 2500. I'm going to first start by getting our e value by itself. So I'm going to divide by 100, giving me e to the power of 0.08 t equal to 25. I know that to undo e, I can use the natural log, because the natural log, if you recall, is the same as saying log base e. Or if you'd prefer, you could use log base e of e to this power. It doesn't matter to me. But if we multiply both of these sides together by the natural log, what we do to one side we do to the other, what ends up happening then is that this piece cancels with each other, so I'm left with 0.08 t equal to the natural log of 25, which we know is a decimal of some kind. But now I can get t by itself by dividing by 0.08 on each side, giving me the natural log of 25 over 0.08. So again, this would be our exact answer. And about 40.2 is our answer as well. So I could also check using decimals. I could set y equals to 100 e to the power of 0.08. Again, decimals doesn't like any other values besides y or x, so I'm going to replace our t value with x. And then as well as y equals 2500. And I would see they would intersect at about 40.2 for our x value. Keep in mind this is a pretty large number, so you would have to set your screen so that you could see it. Okay. Solve 4 to the power of x plus 3 equal to 3 to the power of negative x. So our bases are not the same, but I'm going to multiply each side by the logarithm so that I could use our properties of logarithms. When I multiply each side by the logarithm, I can now take my exponent using my exponent or my power rule and bring that x plus 3 out in front. Notice I kept it in parentheses because they belong together. So I want to take x plus 3 times log of 4 equals to negative x log of 3. Now we can distribute our log, giving me x times log of 4 plus 3 times log of 4 equals negative x log 3. I'm going to bring all of my x values together. So notice this one and this one have x values. So I'm going to subtract 3 log 4 and add x log 3, giving me x log 4 plus x log 3 equals negative 3 log 4, since I brought this one to the right-hand side. Now I see that both of them have an x value, so we can factor the greatest common factor of x out front, leaving me with log of 4 plus log of 3, which are just numbers now. So to get x by itself, I can divide both sides by our just numbers and do to the right-hand side. Plugging that into our calculator to give us a decimal version, we see that our solution is about negative 1.6737. We also could use and graphically decide where they are using decimals. So I would set y equals to the left-hand side of 4 to the power of x plus 3, and y equals 3 to the power of negative x, and I would see their point of intersection would be here. So a great way that we can use our graphing calculator to verify that what we found algebraically is true. Now they can get a little more complicated. Here I have e to the power of x plus e to the power of negative x minus 6 is 0. Okay. What we're going to do first is write this value using a positive exponent. I have a negative exponent, so if I move it to my denominator, it becomes positive. Now I have a denominator, so I'm going to multiply everything by my common denominator. The only denominator I see is e to the power of x, so that narrows it down. So I'm going to multiply everything by e to the power of x such that I can get rid of my fractional pieces. So when I multiply e to the power of x times e to the power of x, note that we have multiply our bases, we add our exponents. So our base is e, we add our exponents. X plus x is 2x. When I multiply e to the power of x times 1 over e to the x, this piece cancels with this one. So we're just left with positive 1. And e times negative 6 gives us negative 6e to the x power. Also, when I take e to the x times 0, we know anything times 0 is 0. So now I'm going to rearrange our items. So I'm just going to flip-flop these around. So notice my exponents are in descending order. I have the power of 2x, x, and then no values. We're going to use substitution to write this in a quadratic form. So we're going to use substitution to write in quadratic form. So I'm going to let u equal e to the power of x. Therefore, if I square both sides, u squared is going to be e to the power of 2x. So I'm going to replace my e to the power of x, which is squared, with u squared, and e to the power of x with just plain old u. These look much nicer to solve and to factor, but there's nothing that multiplies to positive 1 and adds to negative 6. So we're going to have to use the quadratic formula to get us there. So the quadratic formula, we know we need an a value, a b value, and our c value plugged into the formula itself. So when I plug them in, I have u is equal to opposite of b plus or minus the square root of b squared, so negative 6 squared, minus 4 times a, which is 1, times c, which is 1, all over 2 times a, which is 1. So now we'll simplify a little bit. The opposite of negative is positive. So negative 6 squared is 36. Subtract 4 all over 2. 36 minus 4 gives us 32 all over 2. 32 is the same as 16 times 2, and I can take the square root of 16, which is 4, leaving me with 2 on the inside. Note that all of these pieces are divisible by 2. So 6 divided by 2 is 3, 4 divided by 2 is 2, square root of 2. But this is what u equals. We have what e equals.